If you've ever sat there staring at a blinking cursor, waiting for an AI to finish thinking through a really complex prompt, you've experienced one of the most fascinating paradoxes in tech right now. Basically, as artificial intelligence gets smarter, it usually gets significantly slower and way more memory hungry. It's because when we ask an AI to use chain of thought reasoning, which is essentially asking it to show its work step by step, we inherently bog down its speed and just chew through its memory. It's a massive, massive bottleneck in machine learning today. So welcome to today's Explainer. We're going to be diving into a groundbreaking new research paper called MemoSight. And honestly, this paper proposes a totally elegant, unified framework that promises to solve this exact bottleneck. We're talking about making complex reasoning not just possible, but incredibly efficient. Here's a quick roadmap of what we'll cover in this Explainer. First, the AI speed limit. Second, 2 pieces of the puzzle. Third, introducing MemoSight. Fourth, the mechanics of MemoSight. And finally, number 5, breaking the speed limit. Let's get right into it. Section 1, the AI speed limit, the cost of thinking. To really get why this new solution is so clever, we first need to understand the massive computing cost that comes with chain of thought reasoning. Whenever an AI thinks step by step, it leaves behind a very heavy computational footprint, which is stored in something called the KV cache, or key value cache. Think of this as a temporary memory bank that stores previously computed data for every single token, and a token is just a fragment of a word that the AI generates. The issue here? It grows linearly. So the longer the AI thinks, the larger this cache gets. It creates these severe latency and memory bottlenecks, literally to the point where standard AI models will just flat out run out of memory when they're tackling complex multi-step problems. Section 2, 2 pieces of the puzzle, incompatible solutions. Now, researchers obviously haven't just been sitting on their hands. There are actually 2 existing, really promising fixes to this caching problem. The frustration is that, until now, they've been completely incompatible. These 2 paradigms are context compression and multi-token prediction. Think of context compression kind of like taking bulleted meeting notes. It shrinks the past. It takes a long, rambling reasoning step and condenses it down into a few tight memory tokens. That lets the system toss all that verbose, bulky text right out of the KV cache. Multi-token prediction, on the flip side, is all about speeding up the future. It trains the model to predict several tokens ahead simultaneously, kind of like an eager friend trying to finish your sentences for you. Both are fantastic ideas on their own, but combining them, historically that's been exactly like mixing oil and water. See, context compression usually involves post-training these specific memory tokens. Multi-token prediction, though, usually requires completely changing the core architecture of the AI during its pre-training phase, like actually bolting on extra prediction heads to the neural network. So a naive mashup of these 2 methods just completely fails in standard models. The training paradigms clash, the optimizations conflict, it's a mess. Section 3. Introducing MemoSight, the perfect synthesis. And this brings us to the hero of our story today. MemoSight elegantly marries these 2 approaches into one unified framework. And the kicker? It does it without requiring a single change to the model's core architecture. It's a brilliant, purely data-centric synthesis. MemoSight pulls this off by using simple, special tags as carriers for efficiency. It introduces M tokens for memory, which handle compressing those past steps we talked about, and F tokens for foresight, which trigger the prediction of future tokens. Because this is a minimalist, data-centric design relying solely on these special text tags, you don't need some massive architectural overhaul of your transformer blocks. You just teach the model how to use these new tags during fine-tuning. It's that clean. Notice the sharp contrast in approaches here. On the left, we've got the clunky vanilla chain of thought, right next to the context compression framework, which uses those M tokens to replace part of the response. But look over at the right side. Traditional multi-token prediction requires layering on multiple green language model heads. MemoSight's approach, however, uses just a single LM head. It simply interleaves special register tokens, those F or foresight tokens, to achieve parallel future prediction. It is remarkably sleek. Section 4, the mechanics of MemoSight, under the hood. So how does the engine actually organize all these different tokens without getting totally confused? Well, it comes down to what the researchers call position-aware alignment. Think of position IDs literally like assigned seats in a theater. Notice those red foresight tokens? Their seat numbers are mathematically shifted forward, so they project ahead into the future. Meanwhile, the green memory tokens at the end of the block share interpolated seat numbers or position IDs with the preceding reasoning step. This essentially anchors them as a condensed summary of the past context. The model learns exactly what its job is based entirely on the positional math of these special tokens. Now, you might be wondering, wait a second, if an F token is predicting the future, won't it accidentally leak future information back into the main reasoning chain and corrupt the whole thought process? That's where MemoSight's unified attention mask comes in. This custom mask structurally isolates the foresight branches. The blue squares map out what each token is allowed to look at or attend to, so the foresight tokens are totally isolated, acting as independent predictive branches to guess the future, without polluting the main causal chain. So during actual use or inference, MemoSight runs this incredibly brilliant three-step loop. Step 1. Accelerate. The foresight tokens draft multiple future tokens in parallel. Step 2. Compress. Once a thought step is done, the memory tokens condense that specific step. And finally, Step 3. Evict. The system clears the bulky, verbose reasoning tokens out of the KV cache entirely, keeping only those highly compressed memory tokens. Let's actually trace this accelerate then compress loop in action. During the acceleration phase on the left, the red foresight tokens draft future tokens, which are quickly verified. Then, once a step is complete, shift your attention to the right side. The green memory tokens are generated, and then, see that red strike-through over the raw reasoning tokens? That is the evict step. Those verbose tokens are dumped from the KV cache, erased. This continuous loop keeps the memory footprint incredibly low from start to finish. Section 5, Breaking the Speed Limit, the Hard Numbers. All this theory is absolutely fantastic, but, does it actually work in practice? Let's look at the concrete data across major AI benchmarks like GSM-8K for math and MMLU for knowledge. The first number you absolutely need to know is 66%. By constantly evicting those verbose tokens and only keeping the compressed memory, MemoSight achieves a massive 66% reduction in the KV cache memory footprint compared to standard vanilla chain of thought. That is a game changer for hardware limits. But it doesn't just save space, right? It goes fast. When paired with speculative decoding, which is a technique that rapidly guesses and verifies those foresight drafts, MemoSight hits an impressive 1.56 times inference speedup. You're getting your answers significantly faster, all while using a fraction of the hardware memory. Take a look at the trade-offs in this efficiency analysis. Even if you crank the compression ratio way up to 8x, meaning 8 reasoning tokens are crushed down into just one memory token, MemoSight still consumes far less memory than rival compression methods like LightThinker. And it does this while actually maintaining superior accuracy. It's highly, highly robust. And looking at the head-to-head data on the Qwen 2.5 model, the results are really definitive. Vanilla COT gives you high accuracy but hogs a massive 7,184 peak cache tokens running at a sluggish 15 tokens per second. MemoSight drops that cache all the way down to 2,102, maintains an incredibly high 89.84% accuracy on GSM-8K math, actually improves accuracy on GPQA, and rockets the speed up to nearly 31 tokens per second. It really offers the ultimate efficiency performance trade-off, zero sacrifices on complex reasoning power. Which leaves us with a truly fascinating question to wrap up on. We've just seen how MemoSight unifies compression and foresight to fundamentally remove the penalty for deep thinking. So if an AI can now think for hundreds or even thousands of steps without grinding its memory to a total halt, how complex is AI's chain of thought going to become next? When the speed limit is completely gone, there is literally no telling how far the reasoning can go. Thanks for joining me on this explainer, and keep questioning the limits.